Hi, I'm Brandon Graisley. I teach high school computer science, and for my grade 12 class, I was doing a little bit of review of arrays in Java, and I had a few questions. And so, what I thought I'd do is go through each of the tasks that I had assigned and show how to complete each one. Now, if you're in my class and you're looking at these tasks, please don't watch this video until you've legitimately tried each of these activities. I'm going to do them in order, so if you're stuck on number 2 here, after you've watched this video and have helped yourself out, go back and try 3, 4, and 5 before you continue through the video. So don't cheat yourself, do the hard part, which is the learning part, practicing by using the arrays, writing the code. Don't skip ahead here and just watch this and think that that's going to be the same as writing the code for yourself. Okay, so if you're still with me and you're ready to start watching, let's start by creating an array of integers. The array has size 1000. We're going to fill it with the values from 1 to 1000 in ascending order. So to declare an int array, we do that, and I'm just going to do something like this, a really descriptive name. It's going to be a new int array, and it has 1000 cells, or 1000 elements. When we declare an int array, they start off all being 0, so we're going to use a loop to fill them up. And to do that, we need to often use I, the letter I, starting at 0. I will be less than 1000 because we only want to go up to number 999. That will be the reference for the last element in the array, and each time we're going to increase I1, that's the increment operator, the same as I equals I plus 1. Each time through, I'm going to take my array, I'm going to take the spot I, so we'll start at my array at 0, my array at 1, my array at 2, and so on. I'm going to set its value equal to the number. Well, let's see, let's double check. Oh, I want to fill it with values 1 to 1000, so I don't want to fill it with just I want to fill it with I plus 1. That'll be the number 1 when I equals 0. When I equals 1, I plus 1 will be 2, and so on up to when I is 999, I plus 1 will be 1000. So that's how we do it. That will complete the first task of filling my array. Now if instead I want to create an int array with the same size and fill it with the values 1 to 1000 in descending order, from 1000 down to 1, there's a couple of ways to do that. One way is to simply make a change right here. Instead of putting in the value I plus 1, I want to start with the value 1000. So what I'll do is 1000 minus I. Through that'll be 1000 minus 0, which is 1000. The second time through it'll be 1000 minus 1, which is 999, and so on. When I is 999, 1000 minus 999 will be 1. The other way to do that is to do things in the reverse order. Start with a different I value and decrement I, decrease it. I don't think that's any easier though. I think this is probably the simplest and most straightforward way, filling the array in order from the beginning to the end. Just the numbers that are going in are decreasing. Okay, let's create an array of characters, char, of size 26, and we're going to fill it with the values a through z. Those are the lowercase a through z. We're going to use a loop, and we're going to use casting, which we did in another activity. We're going to use the ASCII values for these characters. We're going to use the numbers themselves. We're not going to type in the letters A, B, C, and so on. That's not very practical. And the ASCII values are 97 through 122. So let's get rid of all this and start with a char array. Now let's get a little more creative. That's the alphabet. It's a new array of char size 26. And actually I don't know off the top of my head what the default char value is. It could also be 0, which isn't a printable character. And then our index, which is what the I is standing for, I suppose, starts at 0, the 0th element of our array. It has to be less than 26. We'll go from 0 to 25, increasing one at a time. And now the alphabet character I, so when the first character, is going to be, let's see, it's going to start at 97, right? Yeah. And then each time through, we're going to add one more. Well, the second time through the loop, I is going to be equal to 1. The third time through the loop is going to be equal to 2, and so on. When I get up to the 25th time through the loop, I will be the 26th time through the loop, I will be 25. 25 plus 97 is going to be 122, which is the value that I want. Now, this is a number. It's not a character, so to be really careful, I'm going to put this in brackets. This will evaluate to a number, 122 or 97 or 105, and then I'm going to cast that to a character. I'm going to say, yep, I realize that this is not just a number that I'm stuffing into this, it's actually representing a char value. So this casting is required so that Java knows that I'm aware that this number is to be fit inside of this char variable. For example, if this number, so this is done here, I'm just going to change something here. If this number was a really big number, like that, that's not a normal character value, right? Or maybe something like this, not a normal character value. But by casting it to char, you're telling Java, I'm aware of what I'm doing. I know that this is unusual, and please go ahead and do it anyway, even though it sort of, not breaks the rules, but it's a little bit unusual. Okay, let's do a string array, size 10, and we're going to fill it with special strings. So let's start by making the array, and then we'll go back and take a look at the details. It's a string array of size 10. New string array of size 10. Okay, that part is pretty good. And each time through we're going to do something, so I'm going to start by making my loop right now. I less than 10, I plus plus. Okay, and let's see, each time through we're going to have, a string is going to be this is element number, where x is the current element index starting at 0, so 0, 1, 2, 3, 4 up to 9. Well, you know what? I'm going to be reusing something over and over again here. So I think what I'll do is I'll make a string, and I'm going to call it prefix. This is element space. That's going to be the string, and to that string I'm going to stick on that extra value, the current letter, the current index. So my strings at position I becomes equal to, let's see, I want it to be the prefix plus the index, a semicolon. Now this plus is not the adding operator the way it is with normal numbers, because this is a string, so this becomes the concatenate operator, which takes two strings and mushes them together, and Java says, whoa, this I is an int, there it is up there, int I, but I know how to deal with that. I know how to turn that into a string. So Java does that automatically for us, turns that into the string representation of that current number, and appends it, or sticks it on the end of, prefix. So I'll have this is element space 0, the digit 0. And this actually is constructing a new string and sticking it in there. So that's how it works. This original string is still handy there. It's still available for us the next time through, which is why I wrote it outside the loop. I'm not making a new prefix string each time through. This wasn't even exactly necessary. I could do this. Just get rid of the prefix altogether and just do that. But what this would do is create this little string and then create a new string, which was the concatenated version, the combined version of both of them. That's a little wee bit less efficient. So you're better to just build it out front here and then use it. You're not going to really notice a difference in something this small, but in a big application you might. So hey, we're done 4 of these now. Let's do the last one. Create a double array of double values of size 20 with the values of this form where x is the element index. Okay, let's create our double array. Double array, call it my numbers, is a new double array of size 20. You can see I've done for loop construction a few times in my day, and now this is the form that is going to take 10 divided by x plus 1, where x is the current element index. Okay, I can handle that. My numbers at I becomes equal to 10 divided by I plus 1. Now these are all doubles, so we can just leave it right like this. You can just try it out and it'll stick things in here. Another option to be really safe, and I would actually have to try this to be 100% sure, if you put a D here, that says this is not just a 10, it's a double 10. It's like 10.0. It's please make this a floating point number with the precision that a double contains. And then the division that takes place after this will be floating point division, not integer division, which is done differently in Java. So to be extra careful, and I would be, do this. Make this 10D on top, and now you'll get the values 10 divided by 1, 10 divided by 2, 10 divided by 3, and so on, the way that we want for this application. So that's how we make a whole bunch of different arrays for different purposes, and I hope that clears up any misconceptions. And now if you have any specific questions about how to do any of these based on the code that I've shown you, please email me with those details, or you can comment on the video and I'll explain it right there. That's fine too. But reference which one you're talking about and which part of this code isn't making sense to you, or if I made a mistake. I hope not, but it is fairly late at night and that does happen. If I made a mistake, please let me know that as well, and I'll post a correction in the comments on the video. Thanks.